Now, students, we will look at the multi-facility location. We were talking about like a new facility to be located. And for that, we have discussed the rectilinear location model. We talked about the Euclidean location model. We also talked about the weighted factor analysis. Now, what is actually, first of all, we should know what is multi-facility location or what type of problems they actually pose. The problem of locating more than one new facility, that is n new facilities. Of course, it would not be done simply by using the rectilinear or the Euclidean distance models. With m existing facilities, it's actually trivial when n is equal to m. Simply locate one new facility at each of the existing facilities. If both are equal, then it's become trivial. Trivial in a sense that is actually one for one kind of a scenario. The problem becomes much more difficult when m is greater than n. That means you have more existing facilities and the new facilities are lower in number. Then you cannot have like one-to-one kind of a scenario. You cannot make it trivial. Trivial in a sense that you can just solve it with the help of a rectilinear or Euclidean location model. The problem can be addressed by considering open and continuous solution space and transportation cost. You have to actually assume the continuous solution space in which your optimal solution is actually present, rather than taking it at just as a flow from one department to the other or from one facility to the other facility. Locating a new warehouse to serve the existing plants and markets, breaking bulk terminals for an LTL, that means less than truckload networks, locating storage areas in a production facility and constructing firm stations in a city, fire stations in a city are some examples of multiple facility locations. That means existing facilities might be more than the new facility. So that is actually, I need to locate some warehouses to serve my existing plants. My plants could be higher than or more in number than my warehouses which I am making. Same problem, multi-facility problem, location problem. I need to install some fire stations in a city. And of course, the fire stations would be few as compared to the volume of or the number of residents in a city. So these are all type of multi-facility location problems. The first approach is to cluster the existing facilities into pre-specified groups and then locate one new facility to serve each group. Yes, it can be like simplified. We need to make cluster on some criteria. So on the basis of cluster, your existing facilities would be in let's say 1, 2, or 3 groups. And then you would locate your new facility to those clusters. So one cluster would actually represent one existing facility in this case. The second approach is exhaustive in nature. Each of the n-1 new facilities is assigned to one of the m-1 existing facilities. You have to repeat this. The optimal location for the one remaining new facility is found based on the remaining n+1 existing facilities. The total distance or cost of the above assignment is computed. This is repeated for all possible assignments. It's just like an assignment problem, but it would be exhaustive in nature. One facility, in simple, the simple concept would be there would be one facility, and that one facility would be located to one existing facility, and you will do the allocation, you will do the assignments. After that, you will repeat it with a different combination. And you will do all the possible assignments, and it will become a combinatorial problem if you have m and n to be very high. The corresponding total cost, and every time you will be calculating the total cost and the total distance, are computed, and the assignment resulting in and after all the enumerations, after making all the combinations, whatever assignment had the lowest cost or minimum total distance would be selected. you would know it. This second approach is actually very, it becomes complex because it's exhaustive in nature. Exhaustive means you have to make every combination, you have to make every assignment. तो आपके पास अगर 3x3 भी हो तो आपके पास combinations 9 बन जाएंगे, and you have to calculate the cost, and so that means it becomes quite cumbersome by hand. But of course softwares are there that would actually make the assignments and they will calculate the cost, but by hand it would be difficult. But this approach is common as well. You will make, like the first approach was, pehle jo approach thi, that was just make a cluster. It's more of a simplified approach. Might not give you the best solution, but it will give you a good enough solution. Cluster existing facilities का बन गया जिनके characteristics एक दूसरे से मिलते थे. The characteristics would be on the basis of demographics, might be on the basis of the population, might be based on the different characteristics which Ghosh et al. Actually showed in his research in 1987. So you just cluster them and allocate the new facility to it. Or the other thing is like looking at each and every existing facility and assigning the new facility to it, and then calculating the cost and the distance. And you repeat it for every assignment, for every combination. And then after that, you will look at the least cost and the minimum distance. Thank you.